Inequalities. Inequalities, when you have this in front of a word, equal, it means not equal, okay? Inequalities are any kind of mathematical operation that's not equal. And so those would include not equal. It's simply an equal sign with a line through it. That means not equal. We also have a greater than. And less than. And you can remember the difference between greater than or less than by imagining the number line. This way is less, and so you can see the sign for less, less, and this is greater. Some people get these mixed up because they were taught about alligator mouths, and they were never taught which is which, just which way it pointed. Now on the number line, the numbers that go this way get bigger and bigger. So this is the greater than sign. See it? This is the less than sign right here, and not equals. Okay, now when we solve an inequality, we actually are going to be able to solve it. Hang on, I have another student coming in. We're actually going to solve it exactly the way we solved our equalities. Good morning, Simon. So let's start with the first problem. It's actually going to be quite easy to do if you are getting good at solving equations. These are the same, only they have one extra step that you need to remember when you're doing inequalities. So let's look at number one on the first page, and I'll show you how this works. We're on this page. It says ES1 at the top. And the first one starts with 2x plus 5 is greater than 13. Oh yeah, I remember what else I was going to tell you. Let's do this right here. We have the not equals. We have the greater than, the less than, but then you're also going to see the greater than with an underline in it. This means or equal to. So this means it's equal to it. It's everything that's bigger than a number and equal to that number. This one simply means everything that's greater than a certain number. And you also have a less than or equal. Okay, so these five are the ones that we're going to be working with. So let's do number one so I can show you how this works. Number one says 2x plus 5 is greater than 13. Now we're going to use every single rule that we did when we were solving equations. So we're going to put our line down through the sign, and we're going to circle our variable. Same thing. And we're also going to use the same step. Since we circled the variable and it's on this side, we're going to focus on this side. In order to get the x by itself down here, we're going to have to get rid of the 2 and the 5. And we found out when we were doing equations that we get rid of the straggler first. So since it's a plus 5, we're going to subtract 5, still exactly the same type of steps that we did before. The plus 5 and the minus 5 zero out. And we have 13 minus 5 is 8. But when we bring down the sign, be sure and bring down your inequality sign. That one's hard to remember for a while. And we have 2x left here. You're going to circle your variable, which says we're going to focus on this side, and we have to get rid of the 2. The 2 is multiplied, so we divide by 2, and we divide by 2. Again, nothing is different. Any number divided by itself will be 1. And when we say 1x, we leave the invisible 1 off. Bring down your sign. 8 divided by 2 is 4. So instead of this saying x is equal to 4, it says x represents every single number that is bigger than 4. Now, it doesn't have that line on the bottom, so it's not equal to 4, but it's everything bigger than 4. Now, on the first page, you don't have to graph these, but I want to make sure that you go ahead and see the line graph for this because we're going to on the next few pages. So what we're going to do is you draw a number line. Now, I don't get into having to put marks every single place. What I like is I put where 0 is, so I kind of know these are the positives and these are the negatives. And then the next one that I put on my number line is what I call the important number. It's the important number because it's in the answer. So if I did this, 4 is about right here, okay? And since it's important, I'm going to circle it right here on the line. Now, when you graph an inequality like this, there are 2 things you have to decide. You have to decide, first of all, will this stay an open circle or will it be colored in? The only time this is colored in is when x is equal to 4. In this case, it's not equal to 4, so we leave it open. It says it starts at 4, but it's really not equal to 4. And then this is saying that x represents every single number that's bigger than 4. So you're going to start at the 4 and color everything that is bigger. And you color the arrow because that means all the numbers that this represents are all of these numbers forever. Everything that's bigger than 4. Notice we didn't color in the 4. If your problem said equal to, this equal to is when we color in and say it's not only equal to all these numbers, but it's also equal to 4. Do we have any questions on your first example? Good morning, Simon.
Good morning.
Say it again. Yes. It looks like this. Solving 2-step inequalities. We got this. We might have gotten it on Friday.
Yeah, I already did it.
You haven't done this. Yeah, I think remember Friday you worked from home? Okay, so I'll pull it out in a little bit if you want to take notes. Okay. Okay, any questions here, guys? Isabel,
No.
Sherry,
No, ma'am.
Simon?
No, I'm
Okay.
fine.
I'm good.
All right, then let's do another one. I want to show you the one thing that we're going to have to do. I don't even know if it comes up here. I haven't looked at this yet. Okay, I'm just going to do an example then. I'm going to make up a problem. It doesn't come off your worksheet, but I need you to see because at the beginning of this recording, I told you that working inequalities is exactly the same as when we were solving equations, except for one thing that you must remember. Okay, so let's do this. I'm going to make this up. 6 minus 4x is less than or equal to, let's see, we're going to minus 10. Yeah, let's do 10. Okay, so here's an example that it's just made up. It's not on your worksheets, okay? Okay, so solving an inequality, these are called inequality signs because it means not equal. So, but we're going to solve these exactly the same way. So we draw our line down through the sign, we circle our variable, and then we decide, do we get rid of the -4 first, or do we get rid of the 6 first? Now, the 6 sign is always in front to the left, so this minus or negative goes with the 4, and this plus goes with the 6. 10, since it doesn't have a sign, has a plus on it. It's an invisible plus. Okay, so if we want the x by itself, I'm going to have to get rid of this or this. This is the straggler. We're going to get rid of him first. So we're going to -6 and -6 over here, just like we've done all along. This becomes 0. And when we bring this down, it was minus, but minus and negative work the same. So now I have a -4x, because I had to bring the sign with it, is less than or equal to 4. Is everybody okay where we are now? Okay. So this one, we circled the variable again, which means I need to get rid of the -4. Now it's very, very tempting when you see this negative to go +4. But the -4 is hooked to the x by a multiply. So that means I have to divide. I divide by -4 and I divide by -4. Now, here is the step that I want you to remember. If in an equality, if you divide or multiply by a negative, that's the only time. If you divide or multiply by a negative, the next step, you switch the inequality sign. I divided by a negative right here. See where I divided by a negative? That tells me that I have to change this. So my next step flips the sign. Now everything else is the same. The negatives cancel out. The 4 divided by 4 is 1, so I have x. And this is a positive divided by a negative. 4 divided by 4 is 1. Positive divided by a negative, go back and study your negatives, positives, is a -1. This is the only thing that's different. And you only switch the sign if you divide or multiply by a negative. If you add or subtract a negative, no big deal. If you divide or multiply by a negative, switch the next sign. Everybody good? Okay, again, all of these examples, we're going to go ahead and graph those also. So since it has one variable, it's only going to have one line, our number line. And before some of you came in, I'm not one of those that has to see every little mark on a number line. I want you to make sure that I can see the 0, so you know that separates the positives from the negatives, okay? And then the next thing I want you to plot on this number line is our important number, which is the answer. So -1 is going to be right here. That's the important number. It's right here. And because it's so important, we're going to circle it. Okay. Now, from this point, since it's an inequality, you have two choices to make. The first choice is, do I leave this open where it's a clear circle, or do I color this circle in?
Leave it open.
Good, good. You color it in because it says x is not only equal to every number that's bigger than -1, it's also equal to -1. If it has this sign, it says it includes -1. So if it includes -1, I need to color it in when there's this line. Now, the other thing that you have to decide is, do I color the number line going this way, or do I color the number line going this way? And what we do is learn how to say this word when I answer. I mean, when you read the answer, this one, here it is. Greater than or equal to. So you say, X represents every single number in the universe that is greater than -1. Greater than goes to the right. Less than goes to the left. So we're going to color the entire number line all the way to the right. We color in the arrow because it goes on forever. So that means X could be 0, X could be 5, X could be equal to 17. Could X be equal to -4? No, no. It has to be a number that is larger than -1, or it can be equal to -1. We getting the idea? It's not
It's
too bad.
Deborah.
Yes.
It's Deborah. The sign. Okay, so how do you know, since the numbers are the same, what sign? Because, like, okay, so the signs are different, so you're supposed to subtract and give the sign of the biggest number. So the numbers are the same. So how do you know that it's supposed to be a negative?
Over here for the -1.
Yes.
Those are your rules of negatives and positives. So you have one set of rules for addition and subtraction.
Yes.
If the signs were different, you subtract.
Yes.
But then you have a different set of rules for negatives and positives for multiply and divide. In multiply and divide.
Oh yeah, that's right. It's an odd number, so it's a negative.
Yes, ma'am. Yes, ma'am.
Okay,
You're there.
I got you.
Yes. Good, good, good.
I don't know.
So do you guys understand the one difference? The one difference, if we divide or multiply by negative, we have to switch the very next sign in the next step, okay? So let's try another one. I'm going to do a couple more examples, but then the only work that we're going to do tonight is the first 3 pages of the handout. The worksheet pages I sent to you should have 5. We're going to do the last 2 tomorrow, okay? So let me just pull one. Why don't you all look on the first 3 also, first 3 pages? Okay. We're working this one that says solve 2-step inequalities. Guys, I'm going to pause this and get some handouts for the ones that are here in the class. Okay, we're back. So look through those first 3 pages. I'm going to do number 2 on the first page, number 2 on the first page. But then y'all are welcome to look through here and see if there's any that would give you trouble, and I'll work those. Number 2 on the first page says x minus 4 over 3 is less than or equal to 5. Now, as you use these problems and you write them down for yourself, I suggest that you say to yourself what this says. Don't just look at the symbol. When you see it, say less than or equal to. Less than or equal to, okay? All right, so we're going to treat this just like our equalities, line down through the sign, and we're going to circle our variable. Now remember, this one we haven't done a lot of, but if we have a fraction, remember this top is kind of a set. So let's get rid of this 3 first, and then we'll get rid of that 4. Okay, it seems a little backwards on the PEMDAS, but with a fraction, we need to get rid of this denominator first. Now, if I'm going to get rid of the 3, think again, how is this 3 connected to the rest of the problem? by division, right? Yes?
Yes.
So to get rid of the 3, I have to multiply. I'm going to multiply by 3. Since this was a fraction, I put the 3 over 1 and just made it a fraction because I want to deal fractions and fractions. On this side, I multiplied by 3. So I have to do the same thing to the other side to make sure that this is balanced. On this side, a numerator and a denominator that divide by the same thing cancel out. So what's left on this side is x minus 4. We don't need the parentheses anymore. And then we look to see, what did I do in this step? I multiplied by a number, but did I multiply by a negative? Then there's no reason to change the sign. So I come down with the same sign, and on this side I have 15. Line is down through the sign, circle the variable just like we always have done.
Oh, 3 times 5.
Yes, ma'am.
Okay.
Yes, ma'am. I circled the variable. We're going to focus on this side and say I need to get rid of the minus 4. So how am I going to get rid of a minus 4?
Dividing.
I'm sorry.
Adding.
Yes, we're going to plus 4 and add 4 over here because we always have to keep our equations or inequalities, they have to stay balanced. So when we have the same number but opposite signs, adding those together are additive inverses. They zero out and I have an x left on this side. I bring down this sign. You guys will probably find yourselves putting equals, but go back and change it. Okay, and then 15 plus 4 is 19, okay? Now the x is by itself, so that means we're finished, but we need to be able to read this. We need to be able to read the sign so that we can graph this, okay? So I start at the left and I read. X is less than or equal to 19, okay? So let's graph. Here's your number line. Here's our separation. Now we're going to find the important number. This is the important number. And so I'm going to estimate that 19 is about there, okay? Since it's important, I have to circle it. Very important number. 0 in this case is sort of important. 19 is very important, so circle it. Now, I have 2 decisions. Do I color in the circle or not?
No.
Yes, I do, because it's equal to. If it was just this and not that line, then you wouldn't color it in. But because of this line, it says it's equal to, so our graph includes the 19. And the other decision that you have to make is, do I shade this way or do I shade this way from 19?
On your board, where it shows that the signs were greater than or equal to,
Mm-hmm.
do we not follow those signs you have up there?
Yes. And this says
Less than.
or equal to.
Okay, I guess I'm backwards.
Oh, that's okay. Okay, so it's less than or equal to, so I have to shade to the left, right? Because this is where the numbers go down or go less. And I think, Brandy, before you came in, I was showing them how to keep this straight. If you look at the number line, look at this. This little thing right here is this little thing right here.
Okay, so is it kind of like using this? It's just the 0 in the middle and then going positive and negative.
That's exactly what it is.
Okay.
So if you put all your numbers on here, be -1, -2, -3, you know. But I would rather you'd use all your time to work on the problems instead of putting all the numbers on the number line every time. Do you see what I'm saying? We'll be efficient.
I have a question. With those equal, greater than, and less than, does that always count to color in the dot if it's on greater or less than?
If the line is there.
If the line is there.
See up here, this is greater than,
Yeah.
and this is less than, but these, you don't color the dot in.
Okay.
These, you color the dot in because they have an equal to.
Okay.
That help?
Yes.
Okay. Any questions online remotely, guys? Okay. Now, those of you here in the classroom, did you find another one that you think you might want to work
On 9.
on that same page? Okay. This is number 9 on the first sheet. And then we'll be doing number 6 on page 2 when we get done with this one. Okay, line down through the sign, just like always. Okay. So that means if we circled the variable here, we look at this side of the equation and we decide we're going to have to get rid of 4 and we're going to have to get rid of the 1. This might be a little confusing from the last one, okay? Because the X and something else isn't on top, just an X. So we get rid of the straggler first because this is the best friend. Okay, so we're going to get rid of the 1 first. It's a plus 1 right now. We're going to subtract the 1.
I just noticed that this was not a hard one.
X over 4. Did we divide or multiply by negative? Up here. Did we divide or multiply by negative?
No.
Because this doesn't count, does it?
No.
This is subtraction. It's not multiply or divide. Okay, so we keep the same sign. 10 minus 1 is 9. Circle the variable because it's not by itself yet. So we know automatically we have to get rid of the 4. How is the 4 hooked in this problem? By divide, so we have to multiply. So we're going to multiply by the 4 to get rid of it. And I put it over 1 because it's a fraction. If I do it on this side, I have to do it on this side. I know that the denominator and the numerator divide by 4, so they cancel out. All I have is X over 1 left, and that's an X. Now I come to the sign, and you stop 1 second and say, do I switch the sign or not? Why not?
Yes.
Just tell me.
It's what,
Because
it doesn't have that, it doesn't have
Greater.
greater or less than.
no, not that. When do we switch this to go the other way?
We don't have no negatives. I mean, no.
That's right. That's right. We did not multiply or divide by a negative. That's the only time we switched this. So we looked here, we multiplied, but it wasn't by a negative. So we get to leave the sign the same. And 9 times 4 is 36. Okay, the X is by itself, so we're ready to graph. Now, when I say I don't want you putting all those numbers on there, you can put the numbers on there if you want to. I just don't want you to waste the time doing it on every problem, okay? But if it helps, put your numbers on there. But if you do in this case, you're going to have 1, 2, 3, 4, all the way to 36. Okay? And I'm just going to say, here's 36. Positive 36 is right there. This is my important number. So I circle it. Okay? Now, got 2 choices. Do I color it in or not?
No.
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 Tell me why.
This is not equal.
It's greater.
It's exactly right. It says greater than 36, but it doesn't say it's equal to 36, so we can't color it in. The other thing that we have to decide is which way am I going to shade? To the right, because it says greater than. Yes? Okay, so greater than. Now you don't include the 36 because we're not coloring it in. You have to start at the 36. And there's the graph for this inequality. Is it helping? Okay. I want to work on number 6 on the next page if there's no questions here.
No.
Okay. If you all didn't get the text, I was letting you know that Irene that sits in the back, her father died on
Oh,
Friday. They found him, I guess, in his home. So, and the reason Irene wasn't here on Friday is because she had to go in because one of her co-workers,
Which one's Irene?
the other
The
one.
one over there?
Yes.
Okay.
Yes, this is Mary.
Mary, I'm sorry, I'm still working you guys.
That's okay. Tuesday and Thursdays, it's harder, isn't it? Okay. Yeah, she had to go into work because one of her co-workers had lost a family in a car wreck. And so she already was sad. And I was saying, oh man. And she said, oh, my aunt just called, just found my dad. So anyhow, prayers for Irene, okay? All right, let's look at number 6. This is on page 2. Negative 6x plus 20 is greater than or equal to negative 11x. Okay, now we've worked some of these in the equalities. Okay, so we put the line down through the sign. And we get ready to circle the variable, but it's in too many places. So we're going to have to get them together somehow. We're either going to have to get rid of this one, so he'll go over there, or get rid of that one, so he'll come over here. Okay? That's what you always try to do. But if we take the 11 and put him over here, nobody's there, which is fine. But that's our clue that it's going to cause you to have extra steps.
Well, the reason is because it's 11 and the other one's 20.
Just what we're going to do is, since this is kind of an extra over here with the plain numbers, let's get rid of this guy and take him over where the x's live. Okay, so in this case, it is multiplied. But if we divide here by negative 6, if we divide means to separate. So that's going to separate the negative 6 and the x, and it's going to leave one of them here. And we don't want any x's over here. So in this case, I'm going to get rid of this whole guy, and he is subtracted, so I'm going to add 6 x's here. And if I add 6 x's over here, this only happens when you're trying to get all your variables together on one side. Now, I had negative 6 x's to start with, and I added 6 x's, which made this an additive inverse. They totally left. I have a 20 left, and negative 11 plus 6, that means my answer is going to be negative because this is bigger, right? So negative what? 5. Negative 5 x's. Negative 11 plus 6. If the signs are different, you subtract, use the sign of the bigger looking number. So far, so good. Now the line is down through the sign. I circle the variable. So that tells me now I only want to get rid of the negative 5. I don't want to get rid of the x, right? Just the negative 5. So that is when I can break them apart. I just want the negative 5 to go away, but not the x. Y'all see? So how is the negative 5 hooked to the x? Multiplied, so you have to divide by negative 5. So I have to do it over here, right? Now I'm going to bring down what's left. What's 20 divided by negative 5? Negative 4. And I always stop here and say, okay, this is what the sign looks like. Did I do anything that's going to switch it?
Yes, you did the
I
negative.
did, because I divided by a negative number. If you multiply or divide by a negative number in this step, the very next step, you need to change the sign. Then on this side, the negatives cancel, the 5s cancel, and I have X. X is by itself, but notice that the X is on the other side, right? Yes?
Yes,
Okay, in equalities, we found out it doesn't matter which side the X is on, does it? It
no,
doesn't here either. But it's very important how you read it so that you'll know how to graph. Okay? You can't say X is less than or equal to. Okay? Because it's backwards. Now, there's 2 ways you can do this. Okay? Listen very carefully. You can either take this whole thing like it was written on a piece of paper and flip the paper over. Flip the whole thing over so it would look like this. X, that means flip everything. Oh. And you can make it look like that so that the X is here. This is not mathematical. This is your answer. But if you're going to try to graph, it is easier if the X is on this side. But notice if that was on a piece of paper or a card and you flipped it over, everything flipped, didn't it? That wasn't mathematical. You just flipped a card to make it look easier. Now, the way I do it, and this is easy too, you always start reading your inequality from the variable. So I would start X is, okay? And then I look at this. You can't go by what this says because it's backwards. So the way I remember to read it when it's backwards is this is a big part. And so I say X is greater than or equal to -4.
So you're just reading it back.
Yes, you're reading it backwards. So if it's easier for you to just say X is greater than -4, you can do that, or you can flip your card. X is greater than or equal to -4. See, they're the same thing. Y'all see? It's okay if the X is on this side, but in order to graph, you're going to have to twist your brain around somehow. Okay? So we're going to do it however. We still have the number line. We still put the important number right here and circle it because it's important. The first step we're going to do is decide whether we're going to color the circle in or not. Yes, we are. Why?
yes,
Because it's got the equal.
yes, yes.
Right? Okay, so we color it in. Now, since it's backwards, we're going to have to think, which way are you going to shape? To the right or to the left?
To the right.
Good, good. So you either took your answer, flipped the card, and it looked like this, and it said color to the right, or you read it from the variable. X is greater than -4. Both times, they're greater than. Y'all see? Okay. Any questions online?
No, ma'am.
Okay. I'm about finished unless y'all have one more for me to work on pages 1, 2, or 3. I bet you can do all of these, I think. I don't think there's any surprises. Everything else is what we've done. Let's let you practice now. What does that sound like to y'all? Simon, Sherry, Isabel?
Okay.
Okay. And remember, you can text me or send me a picture and say, I don't know how to do this. And
Okay.
also, I noticed on my printouts, I don't know if it happens when you print your own out at home, but the bottom answers are left off of some of these. So if you need to check the answers, just holler at me. Okay,
Okay.
so for tomorrow, you're only going to work the first 3 pages. We'll go through the last 2 tomorrow. And the 2 things you need to remember: if you divide or multiply by negative, you switch the sign in the next step. Okay, and if the X is backwards on the wrong side, flip your card or read it backwards. Read from the variable. Any questions?
No.
Greater sign.
No, it can be less than, it can be greater, it can be less than or equal to, any of them. Okay, so yes, ma'am, same thing. And I heard, Isabel, you're okay. I think I heard you say, right?
Yes, I'm all right.
Okay, Sherry, you got all the papers in the email?
Yes, ma'am.
Good, are you okay for now?
Yes, ma'am.
Okay, and Simon?
Yeah, I'm okay.
And is tomorrow your test, Simon?
Yes, yes, it is.
Okay, I'll be praying and I want to hear, okay?
Okay, I'll
Good
let
luck,
you know.
Simon.
Thank you.
Okay, love you guys.
Love you
You
too.
too. See you tomorrow.